Hello, sir. Welcome to this quick walkthrough of a student performance analysis using Python and machine learning done on a student met dataset. This was prepared by me, Krishna RATHI, ADITYA MEHTA, and KRITI Sharma. And now we will explore how the data is loaded, analyzed, visualized, and modeled using decision trees, KNN, and support vector machines. Firstly, in the student performance file, we started by importing the necessary libraries and imported the student dataset using pandas. This file performs a deep dive into exploratory data analysis. Firstly, we view the shape and basic structure using dot head and tabulate for formatting. Okay. Next, we visualize age distributions with Seaborn and generate a histogram and box plot of all numeric features. Pie charts are created using plotly.express to show distributions for parental education levels and weekly study time. Then we use count plot to explore how study time varies by gender, failure rates by sex. Count plot was used here. Uh, and Finally, we run the clustering. K means group students based on their grades G1, G2, and G3, and hierarchical clustering shows a dendrogram for students grouping, and this file forms the foundation for understanding our dataset before we build any models.
Whatever has been explained till now, these are the results for the same. These are the tabulate formats of the headers and the columns, and then we have done the histograms, and based on that we have made a box plots, and then these are the parental education based pie charts, and this is a weekly time pie chart, and then these are the more histograms based on the number of failures, study time versus failure times, and school versus reason to choose in school, and these are the pairwise plots based on the given data set, and this is the correlation matrix that we have made, and this is the uh, key means clustering based pairwise plot, and this is the hierarchical clustering based dendrogram, and this is the pairwise plot based on the hierarchical.
Now in this file, the decision classifier, we use a decision tree classifier. After importing all the necessary libraries, we first map categorical values to numbers, like converting m and f to 0 and 1, other categorical data to 0 and 1, so that our ML model can understand. We use only the first 8 features to keep the model simple and predict G3, the other 32 features. And now we split the data, train the model using entropy as the splitting criteria, and print accuracy, confusion matrix, and recall. And after all this, a decision tree is plotted using plot tree to visualize how the model splits the data. Now we use a support vector machine with a one versus one strategy for multi-class classification. We firstly one hot encoded the categorical features and selected 15 relevant features, including grades and behavior metrics like alcohol consumption. The model uses linear kernel and predicts the final grade. We evaluate it with accuracy, a confusion matrix, and a classification report. And then finally, we calculated the ROC curve and AUC for all classes using micro averaging and plot the ROC to show the model's performance in binary classification terms. Now, finally, we use the k nearest neighbors for our prediction. We pre-process categorical features using dot map and get dummies for one hot encoding. Our predictors are all columns except the G3, which is the final grade. We split the data into training and testing the sets using train test split. Then we initialize a KNN classifier with three neighbors and fit it into our training data. And finally, we evaluate the accuracy, classification error, sensitivity, recall, and specificity like we did for the other two algorithms. And here are the results. Okay.
So this was a complete machine learning pipeline on student performance. Visualize analytics with Seaborn and Plotly, clustering to find hidden groups, KNN, decision tree, and SVM classifiers to predict grades, all using real world data and interpreted with clear matrices. This approach not only gives insights into what factors influence student success, but also we have showed how to apply different ML algorithms for practical decision makings.